here is a very interesting anomaly in electrodynamic theory, which we fail to admit to ourselves. It is possible to fake, mathematically possible and electrically possible, to fake the generation of power by not generating it. Due to the fact that there are two different ways of creating the definition of power according to passive sign convention, in which we have negative watts. Current, the polarity of current is opposed to the polarity of voltage. And the normal conventional view holds that there is only one way in which that can happen, and that is called Michael Faraday's law of induction, in which we use a prime mover, namely a significant source of energy lying outside the circuit or the device, to cause the coil of wire to move through space, and hence we pass it through a magnetic field in space, in order to generate current, namely power, inside that coil, when the current is simply a deviation or an additional feature to the voltage of prime mover outside source of voltage being applied to that coil. So we apply voltage to the coil and then we move it. So it's really two things we have to do in the conventional view of reality. We have to apply voltage from a prime mover, an outside voltage source. We apply it to the two terminals of the coil to create a voltage difference between those two terminals, and then we move the coil through a magnetic field. So we have to input magnetism to the field through which the coil is being moved. So it's three things we have to do. Boy, this is complicated. We have to apply a voltage difference across the two terminals of the coil. We have to move the coil through space, and in that spatial domain of movement, we have to create a magnetic field, which is three different prime movers, actually, that we are applying to the situation. And only then, when all three are occurring at the same time in the right way, or in any way, I guess, because homopolar generator proves that. So any way we do it, those are the three factors, and then we get current generated in the coil. Now, we've already applied voltage, so when we get current in addition to the voltage, now we have power. This is the passive sign convention diagnosis of what we have done, is that the current is in reverse polarity to the voltage, and it's fighting us, is what it's doing. We call it back EMF, or we call it the generation of power. Call it what you like, but it's at a significant cost, because the back EMF does not equal the current. Wait a minute. Do we get two currents? A forward current and a back EMF current? That's quite possible. I'm not clear on that part. But in any case, we get current. And the net result is a negative orientation of polarity, of sign orientation, with respect to the voltage being applied. So we call that negative watts, the generation of power. Now, that's the conventional view, is that there's only one way that can happen. But there is another way. And that is when we disassociate the points of space from each other, so that they no longer are electrically communicating in space. So we don't have energy because it can't move. It can't move from point A to point B. It can't take time to go from point A to point B. It starts in point A and then it ends up in point B. Current is supposedly moving voltage differences around to change their balance. And there has to be an imbalance for the current to move in the first place. That's the conventional view of electrodynamics. But if we disassociate the points of space from each other, by disassociating the phase of current from the phase of voltage by a whole half cycle of oscillation, now all we have is time. All we have is, it's called reactive impedance, and there's no longer any resistive impedance. So in a sense, we have superconduction at room temperature because there's no resistive impedance, but there's still reactive impedance. In other words, we don't have the association of points in space anymore. So, resistance creates a perception of space. Because if there's no resistance, then there's no perception of a distance for energy to travel, because there's no resistance. So it takes no... any amount of energy will move energy from one point in space to another. It doesn't take a specific amount. Any amount will do, because there's no resistance to fight. So it's arbitrary how much energy we use. And any amount of energy we do use creates an infinite movement, because there's no resistance to get in the way. So logic just flies away when we have superconduction. Well, there's another way to create superconduction other than lowering the temperature, the absolute value Kelvin temperature of a let's say a coil of wire down to 0 degrees Kelvin, is by disassociating the points of space effectively disassociating them from each other, spatial disjunction. And then we only have time. And that's when we separate the magnetomotive force from the electromotive force by a whole half cycle of oscillation. And that already is the definition of the generation of power, but we haven't done it by moving a coil, by those other three factors that I already outlined. We do it using trickery, so to speak. We use a circuit, a stationary circuit that doesn't move. We use capacitors and we use coils interacting in such a way that that separation between the two components of electricity separation occurs by a whole half cycle within the framework of time, so that we make it look like those three conditions of Michael Faraday's law of induction are in place, when in fact we didn't do that at all. We simply took apart electricity almost all the way. It's still associated in the circuit, but it's not associated in a way that is useful. In other words, we can't spend it, we can't use it, but we can sure hell modify the perception of its quantity, the quantity of that energy, by disassociating it and then warping it, so to speak, out of its original condition of perception of amplitude, how much energy was there. Electrical reactance formula, I always wondered about this. How does free energy happen? Because the simulator does it, but how does it do it? It does it because reactive impedance is the complete situation and resistive impedance is 0. It has no impact whatsoever, because we've separated the phases, so there's no resistance. It's a superconducting state. That's what I mean by a superconducting state. There's no resistive impedance, absolutely none. There's only reactive impedance. And reactive impedance does not occur in space. It occurs in time only, apart from space. Because the reactance formula have capacitance, if it's capacitive reactance, or it has inductance, if it has inductive reactance, and then it has frequency in both cases, and then it has a constant called 2 pi, which describes the angular momentum of one cycle of time. And pi is a transcendental number. And if you multiply or divide or whatever mathematical operation you can think of, you apply it some quantity such as energy, and you apply it to a transcendental number, it's still a transcendental number, which means it cannot be defined by an equation, which means energy in cannot equal energy out. Even though it was that way in the beginning, before we applied electrical reactance to a voltage input of some sine wave at some frequency. Initially, we had energy in the form of a voltage source, let's say 1 microvolt of 1 millihertz. Excuse me, not 1 millihertz, 1 million hertz, 1 megahertz. So 1 megahertz at 1 microvolt. We apply that sine wave to a circuit, or we precharge a capacitor and let it bounce around between two capacitors of very low value, let's say 1e to the negative 13, which is 100 femtofarads, and we'll get an oscillation there, a ricocheting back and forth that creates a certain frame of reference of time, of oscillation, because it'll oscillate back and forth. And so now we've got a very, very low input of energy that's not constant. It's just an initial input of energy, and then we don't put any more in, and yet the energy builds, because it's not the energy that's building; it's the perception of energy that is building. The reactive impedance changes the perception of energy, and it does so in a very convincing way, because when we put the two phases of electricity back together again, namely the magnetomotive force, the two forces of electricity, namely the magnetomotive force and the electromotive force, which appear to us as current and voltage when we measure them. When we put their phases back together again, so that it's no longer 180 degrees shift from each other, now it's zero phase shift because we pass it through a resistor. Now we get this power that we never had before. It might be less, or it could be more. Of course, my desire is to make it more. But in any case, it's different than what it was before, with no additional input or no additional loss of energy, because it was lossless, remember? So we couldn't lose it. And we make sure we don't add any more, so we know that we didn't contribute, and so where did the extra energy come from if the amplitude magnified? It's the perception that changed. And it's because time and both capacitance and inductance and time worked on it. Those are not only the three ingredients of electricity, but they're also, because capacitance is really just a variation of the electromotive force. Capacitance stores it, and inductance stores the magnetomotive force. And a cycle of time stores reactive impedance within a framework of time. But see, the circuit, from our standpoint, we care how many cycles per second exist. But from the circuit standpoint, it doesn't care. All it cares about is using each cycle in interacting with capacitance and inductance to create electrical reactance. That's all it cares about. So if you increase the frequency, you increase the electrical reactance per unit time from our point of view, while from the circuit's point of view, nothing has changed. Time is always standing still. It's always now. And the cycle occurs, but it has no internal reference. We have the reference because we change the pitch, we change the frequency of interactions, of these are self-interactions. Every output from each cycle reiterates. It works upon the result of the prior cycle, so that the reactive impedance changes over time. And that's why the perception of energy changes, because it's now dealing with a different situation. The reactive impedance has changed over time. So the perception of energy has changed. It's not the same quantity of energy, because there has to be some conservation which causes the change in energy. See, when we're dealing with strictly resistive impedance and there's no a reactive impedance like a flashlight circuit, energy in always equals energy out. There's nothing transcendental about it, because 2 pi has not become involved. Angular momentum has not become involved. And that's the nature of DC electricity, is that there's no spinning. The helical shape of a sine wave, we look at it sideways as a sine wave, but if we look at it in three-dimensional space, it's a helix, like a DNA. A DNA is really the path that power takes in a wire. It coils, the shape of a coil, basically. It spins around in a spiral down a line of sight, and it might be a straight line, it might be a curved line, but whatever, it's a helical shape, a coil-shaped path that the energy takes. And that's not DC, that's oscillatory energy. But DC is just a straight line, it's straight. And so there's no frequency, and so there's no reactive impedance. And so the perception of energy is non-changing, and that's the only time that conservation of energy is applicable. Because conservation of energy is describing a zero reactive impedance. That's what it's describing. While it's only describing resistive impedance, exclusively, completely. Because we're looking at space. The movement of energy through space is a resistive situation. But when we change the perception of reality so that space, all the points in space disassociate from one another, and so now all we have is capacitance, inductance, and a cycle of time, now we don't have movement of energy anymore, and we don't have energy. We have the two forces of energy, namely in electrical form, the magnetomotive force and the electromotive force, but we don't have them together to create this illusory condition we call electricity, electrical energy. We just have two forces of nature that by themselves, individually, cannot be measured, but when they come together in some association, loosely or strongly, then we can begin to measure them. But it's a funny thing when they're in a quasi state of union, namely 180 degrees phase shift apart from each other when it's oscillatory. Then the perception of their amplitude can change over our frame of reference of time to become more or less without any more energy entering into the system or any energy exiting the system. Because when it's lossless, it's a two-way street. Not only can you not lose it, but you can't gain any either. In other words, it's not... it's non-interactive. See, that's why you can't lose it and you can't gain it. See, normally energy interacts with each other, and that's why you create, in a resistive impedance situation, energy from one point interacts with energy from another point, and you get this logical condition of cause and effect in space and cause and effect over time. And so we can say that conservation of energy applies. We can say that energy in equals energy out. We can say that we're moving energy from point A to point B. Or we can say that energy has to occur at point A before we move it to point B. Or it has to be produced at point A before we consume it at point B. And then the net result is zero because they cancel each other out. But the situation becomes transcendental, literally, when we involve pi, a transcendental number, because when resistive impedance goes to zero, now the points of space containing energy don't interact anymore with each other. They react with themselves, exclusively themselves, over each cycle of time in a capacitive manner and in an inductive manner. And it either grows, the reactive impedance either grows or it shrinks, but they don't interact with each other, the energy. They only react with themselves. So conservation of energy gets redefined as what it does. The definition of energy gets redefined, which is true because it's not energy. So of course it's being redefined. And I guess what we could say is the definition of energy is how much of the magnetomotive force is interacting with the electromotive force to create a certain quantity of electrical energy, electricity. Which means if we change the storage of those two forces, namely the capacitance storage, capacitance, or the inductive storage, the inductance, if we change the storage, we change the quantity of energy. But eventually, over a certain number of cycles of time, the same amount of change is going to occur. It's just a question if it occurs quicker, if it's a higher frequency from our standpoint. So it takes a certain number of cycles to reach a certain reactive impedance. And when you're dealing with a fixed amount of energy, the reactive impedance, if the reactive impedance changes, the energy changes along with it, even though we didn't put any energy in. This is where conservation of energy breaks down. Now, what I'm describing, I'm not getting there from a logical flow, obviously, but mathematically, or simulatedly, that's what happens. The energy value changes. The perception of energy changes. And for all intents and purposes, the energy changed. Because remember, the cycle of time has no reference of what time is. All it knows is a cycle, Each cycle of iteration, the electrical reactance formula works on the energy that's there by working on the storage of that energy, namely the capacitance storage of the dielectric force, which we call the electromotive force, or the inductive storage works on the storage of the magnetomotive force, namely what we call magnetism or current. When it works on the storage per cycle of time, it changes See, after one cycle of time has occurred, the net result spills into the next cycle. And then the next cycle works on it. And by the time we get done with the second cycle, it's not the same amount of storage as before. So it shows that the electrical energy is simply the junction, the interactive junction between capacitance and inductance within a cycle of time. And if that storage should change, the energy changes with it because it's viewed as a new unit of a cycle. So the two cycles, let's say, if two cycles pass, it's considered the new definition of what one cycle means, is what it amounts to. Because it's lossless, the angular momentum doesn't go away, it simply adds on top of itself. And so that's why whatever direction that reactive formulation takes, whether the diminishment of reactive impedance or the increase, it's not a resistance because we've disassociated the phases by 180 degrees. So instead of it being a positive reactive impedance that would consume the energy, instead it's a negative which generates it. So this is really another definition for the generation of power. Is we're using time as the definition, not a spatial definition of moving a coil, those other three conditions that has to do with Michael Faraday's law of induction. That's his law of induction, but only in a spatial framework. In an electrically reactive, which he didn't know about electrical reactance, so we can't slight him for misjudging or not completely judging the situation because he didn't know any better. But we know better, yet we don't act that way. So I better stay focused here instead of kvetching. So when we take space out of consideration because there's no resistive impedance to deal with anymore, we've already preconditioned the definition for the passive sign convention definition of the generation of power because we've separated the phases from each other by 180 degrees. So already we have a generator, even though we don't have a generator by the conventional method. We already have a generator anyway. And so any amount of power that we put in there is going to change into any other value, depending on which way the formulation is constructed. How we construct that formulation of reactive impedance, it's either going of negative reactive impedance, it's going to alter the quantity of energy automatically every time a cycle of time occurs, every cycle of oscillation occurs. It's going to change it. And when you think about it, a generator, when it's operating under conventional standards of the three points of Michael Faraday's law of induction to generate power in a coil of wire, it's rotating. It's creating its own cycle. What did Jim Murray say about voltage? If he did an experiment with a friend on a substation, they isolated it from the grid so that energy could go in but not leave. so they could do any experiment they want to and not affect the surrounding grid. But they modified I think they totally isolated it. In any case, they used a double value for the cycle time. So instead of 60 cycles, they used 120. And they quadrupled their voltage. And the transformers couldn't handle it, and it blew up, and the whole substation blew up. It was an amazing experiment. And they walked away and acted like, like, did something happen? Like they were clueless. And the electric utility grid lost the substation, but that they weren't really using anyway. Nobody was using it, so it wasn't a big loss. But it was a loss because the whole thing blew up. Because it was 4 times the energy, so it literally squared. And interestingly enough, parametric amplification does work by doubling. Now, in this simulator, that's not the case because it's based on base 10. All the numbers are based on base 10. And so things tend to grow exponentially at the rate of times 10. But in nature, in reality, it's times 2. It's a binary, like a computer. It's by the factor of 2. And Jim Murray, that's another instance of how parametric amplification is defined. It's always by the power of 2. So that's interesting. So they created a purely reactive impedance situation in which resistive impedance was 0. And when they doubled the frequency, they got quadruple the power. Yeah, they would have to. So you see, now where is there conservation of energy in any of that? When you're not even dealing with electrical energy, you're dealing with electrical reactance, which is not energy. When resistive impedance is 0, you're dealing with a totally different animal. It's not even positive impedance anymore. It's negative reactive impedance, because that's the only time you can get resistance out of the equation is when it is going to become negative reactive impedance, because you've separated the magnetomotive force from the electromotive force by 180 degrees. So you can't get anything else but an analogous condition, equivalent to superconductance at, without having to go to 0 degrees Kelvin. It's just at room temperature or any temperature. It doesn't matter. Temperature has nothing to do with it because temperature is a spatial phenomenon. Heat is not electrical reactance. Heat is the byproduct of resistance. And it shows that heat is a resistive impedant phenomenon, not a reactive impedant phenomenon. And so we've literally shanghaied electrical engineering and told them, oh, no, you can't have free energy. You have to have conservation of energy because we have to look at everything in terms of caloric heat loss, heat movement through space, which is not electrical reactance. It's resistive impedance. It's not reactive impedance. I mean, we're totally ignoring, and Wikipedia admits that you can have zero resistive impedance, in which reactive impedance is maximum and resistive impedance is 0. You can have that condition. And yet we go and then turn around and say, no, energy has to always be conserved. Well, always is an interesting term, because always is a time frame of absolute time. Yet in the world of reactive impedance, there is no absolute time. There's simply a cycle of time, which has no reference to anything else. So we haven't reached the speed of light. We've simply isolated a condition in which it cannot be compared to anything else, so we can't get a reference as to time. So from its standpoint, the circuit standpoint, time is not passing. Cycles are passing, but they have no relation to anything else, so it doesn't know minutes or seconds. All it knows are cycles. But the simulator keeps reference so that we can know that it happened within a certain framework of time. But from the electrical reactance point of view, it did not. It simply was a quantity of cycles. That's all it cares about. So time, as we know it, is a reference. But electrical reactance has no temporal reference. It's simply frequency, capacitance, and inductance, and that's it. There's no time there. Even though frequency is a temporal phenomenon, it's not time that can be referenced to anything so that we can say it's how many seconds or how many years. It's simply how many cycles of frequency. That's all that matters. This is a very, deep philosophical inquiry into the nature of free energy. It's not, physics does not explain it. It refuses to explain it. Physics refuses. That's the only way to conclusion I can come to, is that physics refuses to explain it. I just explained it because I didn't use physics. I used electrical engineering concepts to explain it. And then I had no trouble. So long as we keep physics out of the picture, everything will be fine. Because energy does not equal matter when we're dealing with electrical energy. That only deals with nuclear power, because you're dealing with the mass of the atom is mostly in the nucleus. But when you're dealing with electrical energy, you're only dealing with the valence electrons, which are not even the saturated shell of electrons. It's the unsaturated shell of the electrons, shells of the atom of copper or iron or aluminum, that we're dealing with electrical energy. And those valence electrons hold the copper atoms, or holds the iron atoms, or the plastic atoms, or the whatever's holding together the circuit are the valence electrons. And when the energy exceeds that bond, that chemical bond, the whole thing explodes. Or a mechanical bond, if you prefer to call it that. It's a materials bond that holds the materials of the atomic materials together. But that's not equal to the mass. The valence electrons doesn't even come close to approaching the mass of that material. So E does not equal mc squared when we're dealing with electrical energy at all. And so conservation of energy doesn't apply either. And it's no big surprise because pi is a transcendental number. So when you start dealing with a situation in which resistive impedance is 0, you're dealing with something that cannot be equated. There is no longer, you can't apply a formula to say that energy in equals energy out, or that energy moved from here over to there, or that energy disappearing over here can't disappear faster than it's appearing over there, because the over there is not supplying the energy for over here. They're not interacting. Lossless means lossless. It means no component can interact with any other component in an energetic manner involving resistive impedance and voltage drop. It just ain't going to happen. So voltage drop does not apply anymore because the energy is not moving from place to place. Yet it gives the appearance, the illusory appearance, that one component, the energy is disappearing at a rate faster than it's appearing someplace else. So if you do a tally, a total analysis of the circuit at any unit, at any point in time, you won't come up with a zero balance sheet like you did when you did an analysis of a flashlight circuit, in which the energy is appearing at the battery and it's disappearing at the lamp, and they have the same absolute value, just an opposite sign polarity, and so your net result is 0. Balance sheet, assuming no losses to make things simple. But in a zero resistive impedance situation, in which the magnetomotive force and the electromotive force have been separated in an oscillating situation by 180 degrees or a half-cycle separation, you don't get that anymore. There's no logic anymore, because there's no interaction anymore. Every component does its own thing, and it will do it in a different manner depending on how the circuit is arranged. So there is some kind of interaction going on, which dictates how those components behave, but they don't interact. They kind of take their lead from each other in a very loose way, but they still do their own thing in a reactive sense. So in a sense, they still interact reactively. They interact, but they don't interchange energy. Energy doesn't move between them anymore. And yet, by way of passive sign convention, it can make it look like energy is disappearing over in a diode. It's being consumed faster. There's a larger quantity of energy disappearing at the being consumed at the diode than is appearing at the coil. That is being produced at the coil, and it doesn't make any sense how you can have energy disappear faster than it appears. How it can be consumed at a rate greater than what it's being produced. It doesn't make any sense, and still increase. The overall energy in both the diode and the coil increase over time. It doesn't make any sense unless conservation of energy is suspended because resistive impedance is zero. That's literally what occurs. And then reactive impedance takes over and has to be negative reactive impedance, which means the whole thing keeps accumulating. It keeps growing. It keeps self-generating, self-amplifying. There's no other way to look at it. But, you have to take everything into consideration. The transcendental nature of pi makes it possible when resistance is excluded from the picture. And it's not that hard to remove resistance. We don't have to supercool it. We just disassociate the two forces of electricity from each other within every cycle of time.